Assuming you have a performance tuning strategy and a sense of where to start, you may be wondering, why is this even necessary? I thought Power BI was supposed to be fast out of the box, and it is. It's well architected and well designed, but there's a dirty little secret when it comes to Power BI. Intuitive designs simply do not scale. The quickest path to a working solution is rarely the best path to a lasting solution. Oftentimes, the easy solution is to use just one big table, but over time, a report will accumulate more years of data, more pages, more measures, and more logic. And these slowdowns aren't always linear. Sometimes with reporting, it's going to be the straw that breaks the camel's back. So what do I mean by intuitive? Well, intuitive designs are those that are based on experience that you already have or make the data and logic as easy to see as possible. For example, the easiest schema to work with is one big table. If you work with Excel or data exports, this is exactly what you're used to. You don't have to consider joins or relationships. The data is what it is, and the logic is easily understandable. You can get your arms around this. Unfortunately, with one big table, you very quickly find the moment you need to do anything at a higher level of detail, a higher level of aggregation, it breaks down. If you have one big table with every sale ever, and your boss says, hey, can you tell me the average quantity of products sold for each store in each state? It becomes a lot more difficult. Another intuitive design is to use calculated columns. These are way more intuitive than measures. You can see the data. It's pre-calculated. You can see the results. You can validate it. It works like Excel formulas. It all makes sense. Unfortunately, not only do you lose a little bit of flexibility and interactivity compared to measures, but from a performance standpoint, calculated columns are atrocious. And the reason is they are pre-calculated and stored with the data model. So every column that you add makes the data model bigger. And every column that you add makes compression worse. Because of the way the engine stores everything, it'll sort all of the data by column and column and column. And the first few it decides to sort will compress really, really well. And then the next ones, not so much. But calculated columns, at least if you make them with DAX, are compressed last. So they are guaranteed to have bad compression. Finally, if you have a transactional system that you're pulling your source data from, the most intuitive thing is to maintain whatever relationships or joins exist in that system. And that tends to be a very normalized schema. It tends to be broken up into a bunch of little tables. Unfortunately, this scales poorly. You often have a bunch of tables that should be flattened together. Let's say you have product, subcategory, and category. That should all be one dimension, one table. Or you may have many-to-many relationships that in a database engine, it's able to handle it very well. But whenever you bring it over to Power BI, you're going to get poor performance. In all these cases, the things that are easiest to work with rarely are the things that scale the best. In general, though, most Power BI performance problems that I see fall under one of three categories. First is excess data. More data being brought in than is needed. Next is unnecessary or unneeded work. Having Power BI doing donuts in the parking lot, spinning around, so to speak, instead of doing meaningful work. And finally, misuse of the engine. While my Hyundai Elantra can probably drive off-road, it's not designed for it and I'm never going to do it. The DAX and Power Query engines were also designed for specific use cases. And when we misuse that, we can get bad performance. You can use a butane torch to make some toast, but I wouldn't recommend it. So let's walk through each of these three examples. Too much data is a common problem. It's tempting to simply bring in a table as is and start working. I've done it many times before, but very quickly you should be asking, do we need all these rows? Probably not. Many reports will be perfectly fine comparing this year's sales to last year's sales and maybe bringing in a third year just to be sure. Do we need all these columns? Less data on average means better performance. Even if the measures and calculations you're working with don't involve the unwanted columns, it still takes up space and it can still hinder compression for the table that it's in. Sometimes you may have the right amount of data, but you aren't taking advantage of the internals of the system to get the best compression. You may have a date time column and you don't need the minutes or seconds. And so you have a bunch of unique values. And if you were to truncate off the time, you would get better compression and better performance. Well, what about unneeded work? What about wasted effort? Maybe you have that data at that second or minute level and you're constantly aggregating it. Maybe you're bringing in line items for orders, but you only need the order total. In that case, you could pre-aggregate the data once at the source instead of working at the wrong granularity or level of detail. Maybe you're using something like bidirectional filtering when you shouldn't, and you're causing filter cascades, which is when you filter one table and it filters another and then accidentally filters another. The worst case I've ever seen of this was a situation where a customer had a bidirectional filter on the date table. The way that I think this happened was there was a summary table as their transaction table and had one row per day. And so the Power BI engine assumed that it was a one-to-one relationship, and so it turned on bidirectional filtering. And whenever I would filter that summary table, it would filter the date table, and then it would filter every other transaction table in that model. You have to be very careful with bidirectional filtering. Another issue is wasted work in Power Query. Sometimes people will do the same steps, such as renaming columns or changing data types multiple times instead of combining them. Sometimes people will sort a table just to see how the data looks and then forget to remove that step. And Power Query dutifully is just going to keep sorting that data and wasting time. Finally, a lot of people do not take advantage of query folding. They don't know what it is. And because they're handwriting SQL queries to get the data, any transformations they do after are done in Power Query. But if you know how to use query folding, you can push a lot of that work back to the data source and get the best performance possible. Finally, there's some things that the engine can do, but it's not good at and it will never be good at. And these things should be done sparingly or never at all. For example, there is never a good reason to directly implement a many-to-many relationship between two tables in Power BI. Sometimes there's a logical need for it, but often this can be solved by making a new dimension table. If you have a relationship between your fact tables, say inventory and sales. Sometimes this can be solved by creating a bridge table and then setting bidirectional filtering on one side of that bridge table. Another example of misuse of the engine are intertable calculations in Power Query. Power Query is very good at reading row by row in a single query, a single table, and making calculations within that context. But whenever you start to do lookups on another table, or even sometimes with merge joins, you can get bad performance. You want to try to do those things at the data source if you can. Finally, are what I like to call handmade visuals. This is when a report developer uses a bunch of lines and boxes and multiple visuals to make what looks like a single complicated KPI or card visual. But unfortunately, the more items you add on screen, even lines, even boxes, will slow down your reporting. It's understandable if you're coming from a background of Word or PowerPoint where it's perfectly okay to do that. But because Power BI is running in a browser, it doesn't scale the same. And so if you add 50 boxes to your screen, that will slow down rendering, even if you're not doing anything computationally.